Good morning, myself Chaitanya Jyoti from Triple E department. My topic is about filters. Filters is a frequency of selective network that allows only desired frequency signal and stops unwanted signals. Electrical filters, they are classified into two types: active filter, passive filter. Active filter, these are the filters having active elements like a transistor, OP, AMP, and having passive elements like resistor and capacitor. We can't use the inductor because large size. Passive filter, they are made up of only passive elements like resistor, inductor, capacitor. Classification of passive filters. There are classified into four types: low pass filter, high pass filter, band pass filter, band stop filter. Low pass filter, these are the filters that pass all the frequencies lower than the selected cutoff frequency and steps the signal whose frequency is greater than Fc1. Here we see the graphs for low pass filter, high pass filter. These filters passes are the signals whose frequency is higher than cutoff frequencies and stops the signal whose frequency is less than Fc2. Here we see the graphs for high pass filter. Band pass filter. This filter passes gain particular band frequencies. It stops all other frequency. It has two cutoff frequencies: lower cutoff frequency, higher cutoff frequency. Lower cutoff frequency is Fc1 and higher cutoff frequency is Fc2. This signal passes all the signals whose frequency lies inside the band Fc1 to Fc2 and stops all other frequencies. Here we see the graphs for band pass filter, band stop filter. These are stops particular band of frequencies and passes all other frequencies. It is opposite to band pass filter. Here we also see graphs for band stop filter. And next, constant K or prototype filter. A network is said to be constant K type if the series impedance Z1 and shunt impedance Z2 of the network satisfy the relation Z1 into Z2 equals to K square. K square is nothing but R0 square, where K is the real constant impedance of frequency. It is often termed as design impedance R0 of the filter. Here we see the filters for K, constant K filter. Here we see T network and pi network. T network has both inductors are there and one capacitor are there. In pi network, one inductor are there, two capacitors are there. Inductor we are represented as Z1 by 2 and capacitor as 2Z2. And in pi network, inductor as Z1 and capacitor as 2Z2. Here we see low pass filters design and T network and pi network. Here L value is L by 2 and capacitor is C. In pi network, in low pass filter, inductor is L, capacitor is C by 2. High pass filter, we have filter designs. Here two capacitors are there, is 2C and inductor is L. Here in pi network, capacitor is C and inductors are 2L. Here also we consider Z1 equals to j omega L and Z2 equals to minus 1 by j omega C. Z1 Z2 equals to R0 square. 2 pi FL into 1 by 2 pi FC is equals to R0 square. Here equals to Z1 equals to JWL. Substitute in Z1 into Z2 equals to R0 square formula. L by 2 is equals to R0 square. R0 is equals to root of L by C.